Hi, and welcome to Memphis Communiversity. I am Castle. I'm a recent high school graduate, and I took 2 years of calculus in high school, and I'm going to be talking about the chain rule today. If you want to look at this worksheet or work along with me, print it out, whatever you want to do, you can find the worksheet and the answers in the description below. And if you think this video is helpful, then like it and subscribe to the channel because there are a lot more videos of girls like me that are working through different calculus topics. So for the chain rule, if you haven't already seen the videos on power rule, trig derivatives, or product and quotient rule, I would recommend going to watch those or just making sure you understand those concepts because all of them are kind of going to be incorporated into this rule. The chain rule, I think, is one of the harder things that I learned in calculus at first, and then the more examples I did, the easier it got and the more natural it came to me. So if it's confusing at first, just keep watching, keep working through these examples, and I think by the end of this video and the more examples you do, the more easy it will seem to you. So I'm just going to go ahead and get into it. The chain rule is for the composition of functions, which basically means you have a function within a function. And if you haven't seen that yet, this is what it looks like. You have f of g of x, and even when it's in letters, I know it can be kind of confusing, so I'll try to point out those f and g functions as we work through examples. But in this case, I think it's easy to think about it as inside and outside functions. So here, the g of x is the inside function, and the f is the outside function. So I'm going to refer to inside and outside functions a lot and keep referring back to this rule. And so that's kind of what a chain rule looks like, and we'll see more examples of those. And then the rule is that that derivative equals f prime of g of x, that inside function, times the derivative of g of x, the inside function. So basically what it's saying is that you have the derivative of the outside function right there, and then you keep the inside function the same, and then you multiply by the derivative of the inside function. Again, this will make more sense when we start looking at examples. So here I've got derivative of outside. I'll go back to that. Derivative of outside, keep the inside, and then, where'd it go? Keep the inside, and then multiply by the derivative of that inside function. So a pretty classic example of when to use the chain rule would be what I'm writing right now, sine of x versus, let me move my face, versus sine of x squared. So on one of these you use the chain rule and on the other one you don't. So we're looking for the one that has the function within a function. And in this case you have the inside of those parentheses, x, doesn't have a function that goes with it. It's just x. So sine of x, you would follow that rule that says sine of x equals cosine x. But then if you look at this other one, x squared is a function within the sine function. So x squared would be that g of x, and the sine would be the f. So in this case, you would use chain rule and follow that derivative f prime of g of x times g prime of x. So I'm not going to work that one out, but we'll get to some examples that show pretty similar things. So just keeping in mind that you're looking for functions within functions when you're doing the chain rule. So let's get started with some examples. Okay, so on this first example, the first thing we want to do is identify the inside and the outside function. So in this problem, the inside function is pretty clear because it's in parentheses. And so I am underlining that inside function, and then the outside function here would be that exponent 5. And if we're working from the outside in, trying to start at the outermost functions and then work to the inner function, here the outermost function is that exponent. And remember that when you have an exponent, you're going to be using the power rule. So that's the first thing that we're going to do with the power rule. You move that 5 to the front. And then remember, we are keeping the inside function, the g of x function, the exact same when we first do that. And then, oh, I forgot to do the to the 4, but you're going to have 5x cubed plus 2x to the 4. Sorry about that. And then you multiply by the derivative of the inside function. So here the inside function is x cubed plus 2x, and the derivative is 3x squared plus 2. So to try to match that up with this chain rule here, you've got f of g of x would be this function right here, the g of x being x cubed plus 2x, and the f being that exponent 5 equals f prime of g of x. So to do that f prime, you do the power rule, 5 times x to the 3 plus 2x, and I should have a 4 right there. And then you multiply by the derivative of the inside function. So I've got this arrow going from the inside function to its derivative, 3x squared plus 2. So let's go ahead and move on to the next example. And I'm going to be trying to point out different rules for derivatives as we go through this, just to remind you of all of those. But remember to look at that trig derivative video if any of these are confusing to you. So on number 2, the inside function isn't in parentheses, but you can see that it would be 2x plus 5 because the multiplying the x by 2 and then adding 5 are all part of that innermost function with the x. Usually, from what you've seen before, you would just have e to the x, but here all those numbers attached to the x are part of that inside g of x function. So this one isn't too bad. The derivative of e to the x, you know, is just e to the x. So in this case, we're going to do y prime equals e, and then remember you keep that innermost function the same when you do the f prime. So you've got e to the 2x plus 5, and then you multiply by the derivative of that inside function. So here the derivative is just 2. Okay, so let's move on to number 3. On this one, your inside function is in parentheses again, which happens a lot, and then your outside function is that cosine. So remember that the rule for cosine, all of the derivatives with cosine have a negative, so you know it's going to have a negative, and in this case, cosine of x is negative sine of x. So we'll remember that when we do that f prime of g of x. And then just to remind you, I have in and out written, but just remember that this 3 theta minus 1 is the g of x, and then the cosine is the f. So you can keep looking back up here to the derivative written out and kind of try to identify each thing. So remember f is that cosine, 3 theta minus 1 is the g of x, and then kind of follow along here as we work through this one and make sure you understand how that derivative works. So because cosine is negative sine, when you do the derivative, we're going to have a negative sign, and then remember g of x is 3 theta minus 1, and then you multiply by the derivative of g of x. So I've got that arrow pointing there, and the derivative is going to be 3. Okay, moving on to number 4, this is another pretty basic chain rule where you are using the ln of x derivative, and remember that ln of x, that derivative is 1 over x. So in this case, the x squared plus 1 is kind of being substituted for the x because that's our inside function. So I underline the inside function, it's in parentheses again, which makes it easy to recognize, and that's going to be y prime equals 1 over g of x, which is x squared plus 1, and then I've got that arrow pointing to the derivative of the inside function, which is going to be 2x. So remember, we've got f prime of g of x times g prime of x, the g of x being x squared plus 1, because that's the innermost function. So now on number 5, this is something that we want to rewrite. Whenever I see a square root and I'm taking a derivative, I am always going to rewrite it just as whatever's inside the square root to the 1/2, because that makes it a lot easier to work with and it turns it into a power rule problem. So on this one, that exponent 1/2, when we take the derivative, since we're doing power rule, we're going to bring it to the front and we're going to do y prime equals 1/2 times g of x, keeping that the same, 3 e to the x minus 1, and then to the negative 1/2, since we're still doing power rule. And then you multiply by the derivative of that inside function, which is 3e to the x. Okay, Okay, on number 6, this is another example of one where you want to rewrite the original problem to make it a lot easier on yourself. So in this case, I'm going to take that x squared plus 9 and put that to the negative 1. I think that makes it a lot easier to work through. And so now with this, I am going to recognize the outermost function, which would be that exponent to the negative 1, and we know that an exponent is power rule. And then the innermost function, the g of x, is the x squared plus 9. So let's start working through that one. This is going to be y prime equals, we're going to start with negative 6, taking that exponent and multiplying by the coefficient, times the g of x, x squared plus 9, and then to the negative 2, finishing off the power rule. And then we're going to multiply all of that by g prime of x, which is the derivative of x squared plus 9, and that's 2x. Okay, those were some good basic examples of chain rule. And then on number 7, it's going to get a little bit trickier because we're mixing quotient rule with this problem. So the way that's going to work is we have our outside most function, which is going to be that exponent 5, but then as I'm writing, the innermost function is a quotient rule because you have a fraction in there. So I'll try to explain this as we work through it. But remember that even when you have a quotient rule or a product rule or something like that on the innermost function, you still always want to start with the outside function. And recognizing the outside function, a good way I think to do this is to think about it as the very last thing that you would do. So say you're plugging in the number 1 for x, and if you look at this problem, let's get it to focus. Okay, so if you're plugging in the number 1, the first thing that you're going to do is the parentheses. You would do 2 times 1 plus 1 divided by 1 minus 3. And then the last thing you would do is take that number and do it to the 5th power. So the outermost function is the thing that you're going to do last, being that exponent to the 5. And the innermost function is where you start off, which would be everything that's inside the parentheses. So let's just start working through this, remembering that we're going to start with the power rule because we're looking at that exponent. So we do 5 times g of x, keep everything in the parentheses the same, just like we've been doing, and then put all of that to the 4th power. And then when we multiply by g prime of x, that's when we have to look in there and recognize that it's the quotient rule. And we're just going to follow the quotient rule. So we've got low x minus 3, d high, which is 2. Oh, let me move my face again. Okay. D high, which is 2, minus high, 2x plus 1, and then the derivative of the bottom is just 1, and all of that goes over low, or low squared. Okay, so that's what it looks like when you have a quotient rule within the chain rule. Hopefully that made sense. If not, we're going to have more examples, and I think it'll start to be a lot more clear. So now let's just move on to number 8, which is another pretty basic one, but you can make it a lot easier on yourself and a lot less complicated if you go ahead and rewrite that as tan times x to the negative 1 before you start, because again, that just makes it a lot more simple. And just remember here that the derivative of tan x is secant squared x. That's one of those derivative rules that you have to know, and that's one of the harder ones, so just a reminder. So let's just go ahead and work through that one. It's going to be y prime equals secant squared of g of x, which is just x to the negative 1. And then when you do the chain rule, like I'm writing, you're going to do the power rule with that x to the negative 1, bringing the negative 1 in front, and then subtracting 1 to get negative x to the negative 2. So that's your g prime of x. And then I think it looks nice if you just rewrite it as secant squared of 1 over x times negative 1 over x squared, but it's the same thing. It's just rewritten. And I'm not simplifying all my derivatives a lot here because I'm just kind of focusing on the chain rule. But for your class, depending on your teacher, you might have to simplify more. Just wanted to point that out. Okay, so number 7 was a little bit tricky because we had the quotient rule within the chain rule. And then number 9 is a little bit different but it's also kind of a tricky one. You'll get used to them the more practice you do. But on this one, you're going to be using product rule. So the first thing I'm going to do is identify the two things that are being multiplied. Even now, I still do this. I always underline the first function, and then I double underline the second function so that I can just keep track of everything I'm doing while I do the product rule. So here, you're going to have the chain rule within the product rule. And just a reminder, product rule is derivative, keep the same, plus keep the same derivative. Or you can switch it around and do keep the same derivative plus derivative keep the same, however you want to write it. So I'm going to get started here by doing y prime equals, or here I'm going to identify that inside function. I just think that's helpful. So I've got first function underline, second function double underline. That's going to help me through the product rule. And then I labeled the inside function of that cosine just to help me remember that we have chain rule. So now I'll get started with this one. And I'm going to have y prime equals keep the same, that's x squared, times derivative, which is negative sine 2 minus x. And then here is where the chain rule comes in. This gets me, even now, just forgetting these little chain rule things. But because you have a 2 minus x in there, you're doing a function on that x. You have to remember to multiply by g prime of x, which in this case is just a negative 1. So that's the completed derivative of that second part. And now we're going to move on to the second half plus derivative. That's an easy derivative, 2x, and then keep the same. So just remember, even when you have a little negative in front of the x, you have to remember to do the chain rule on that. So this problem is pretty much just a simple product rule problem, but you have to remember that negative 1. It's super easy to forget. Okay, so if that last one with the product rule was a little bit confusing, we are about to do 2 more examples of product rule, so you'll get the hang of it. And I've got the chain rule written up there, so you can just keep referring back to it as we work through these example problems, but I definitely think the most helpful way to learn is through these examples. So let's go ahead and start with number 10. You can see this is another product rule. We have 2 functions being multiplied. And so the first thing I'm going to do, now that I know it's product rule, is to identify the 2 different functions. So I'm going to skip ahead a little bit, and here we go. Sorry about that. Okay, got it. Okay, so I've got the first function underlined once and the second function underlined twice, and those are being multiplied by each other. And then I also labeled the inside functions here. So within that product rule, you have functions that go with the x, the first one being x plus 1, and this other one 2x minus 3. So that's where the chain rule comes into play. Those are going to be your g of x. So let's get started with this one. Remember, we just talked about product rule, so we're going to follow that rule. Let's start with derivative of the first one. So that's going to be 4x plus 1 to the third using the power rule. And then using the chain rule, we're just going to multiply by 1. And you don't have to write the 1. I just wanted to show where chain rule comes into play there. And that innermost function, there's kind of a 1 implied right before the x, and that's where the 1 comes from. So for that one, when we did the derivative of the first part in the product rule, we had to use power rule, and then we had to use chain rule. And then for the second part, we're just going to keep that the same, 2x minus 3 to the fourth. And then now we're going to add, keep the same. Oh, so there I am labeling that first part of product rule and then double underline the second part. And then we add, keep the same, x plus 1 to the fourth. And then derivative, we're going to do a derivative pretty much the same way using power rule with that exponent, and then multiplying by 2, since that's the coefficient of the x. So let's just review that. We've got derivative using power rule, and then chain rule, multiplying by the 1 that goes before the x, keep the same, plus keep the same, And then the derivative here is another power rule, using that for exponent, and then multiplying by g prime of x, which is just a 2 because you've got a 2 in front of that x. Okay, so now we have another product rule on number 11. And then this one I think is good to compare to the one we've done before because it kind of helps you with recognizing what the outermost function is. So the tricky thing here is that the outermost function isn't the product rule, even though there is a product rule in this problem. So in the first one, you can see that we had just a product rule as the outermost function with two different functions being multiplied by each other. But here you've got a product rule within an ln. So the ln is going to be your outermost function, and then everything within the parentheses is your innermost function. So I'm going to label that in, and then we can get started with that one. And remember that ln of x, that derivative is 1 over x. So the first thing we need to do is do 1 over everything that's inside of the parentheses. And then, since there's a function within that parentheses, that function is product rule, we are going to multiply by g prime of x, which is the derivative of everything in the parentheses. And to do that, we have to do product rule. So let's go ahead and do that. I'm going to start with keep the same, 2 sine of x times derivative. Remember that anything with a co is going to have a negative, so the derivative here is a negative sine of x. And then remember that you don't have to do chain rule with that cosine of x because there's not a function that goes with the x. The function is just cosine of x. And then that's our first part and our second part for product rule. And then you add derivative, which is 2 cosine of x times cosine of x. Keep the same. And then I'm just going to underline those again, that first part with a single underline and the second part with a double underline. So just to review this one, we did our outermost function, which is ln of x. The derivative of that is 1 over x. And then we moved to our innermost function, which was 2 sine x cosine x. And to do that, we had to do product rule. Okay, so let's move on to number 12. This is a pretty easy one. It can look a little bit tricky because you've got e to the x, which seems a little bit confusing, but it's just recognizing that the e to the x up there is your innermost function, and then your outermost function is going to be using that rule that says the derivative of e to the x is just e to the x. So in this case, you're going to do y prime equals e to the x, with that small e to the x being your g of x, that stays the same. And then you multiply by g prime of x, which is e to the x. Okay, so on 13, we have another example of a quotient rule problem. So I'm going to write quotient rule. So remember that the quotient rule, the easiest way to remember that is low d high minus high d low over low low. So let's just get started with that. Our low being 2 to the x. And then this is kind of a tricky derivative that you've just got to remember. It's the inverse sine of x, which is written as sine negative 1 to the x. The derivative of that is 1 over square root of 1 minus x squared. So just remember here that your x is actually, you're substituting this 4x into any case that there's an x in the derivative. So since the derivative of inverse sine of x is 1 over root 1 minus x squared, and you want to plug in that 4x anytime you see an x, then that turns into 1 over square root of 1 minus 4x squared. And then you can't forget to do the chain rule here because you have a 4x, you've got a function within a function. So you're just going to multiply by g prime of x. And if your g of x is 4x, then your g prime of x is just going to be 4. So that's your low d high. And then you need to do minus high d low. So that's going to be sine negative 1 4x, or inverse sine of 4x, times, and then this is another kind of tricky derivative that you've got to remember. If you have a number to the x, then that's going to be that number to the x times ln of the number. So in this case, you've got 2 to the x, so it's going to be 2 to the x ln of 2. And then all of that goes over low, 2x squared. And just as a review of those kind of tricky derivatives, I've got them, I'm going to write them out to the side so you can see inverse sine of x and a to the x. Those are just some tricky derivatives. So chain rule comes into play here. Remember with that for x. And then, yep, that's it. Other than that, it's just quotient rule. So now we're going to move on to 14. Okay, 14 is another product rule, and this is another one where you have to be really careful to recognize chain rule, or you could miss just a really small mistake that's pretty easy to skip over. So right here, I'm going to identify my outermost and innermost functions, and my innermost is going to be the one in that parentheses. But then, as you can see, I've got t squared underlined and e to the negative t double underlined because you're multiplying those, so you've got a product rule there. And then the really tricky part here is that you have to recognize another inside function, which is the negative t. So as we work through, I will show you where each of those functions go. Remember that we're going to start with the outermost thing, which is that cosine, and then we're going to keep working our way in and do that product rule. So it starts off with that outermost function, cosine. Remember, co means negative, so that derivative is going to be negative sine. And then everything in the parentheses stays the same. That's all g of x. And then you're going to multiply by g prime of x. So in this case, you've got to do product rule to get the derivative of those things. So I'm going to start with keep the same, t squared times derivative. And so here we've got a small chain rule within a chain rule. All it takes is you need to multiply by the derivative of the negative t. So you've got negative 1. But it's just hard to remember that. So within that product rule, we have got another chain rule. And in this case, since we're doing the derivative of e to the negative t, the g of x is the negative t, the g prime of x is the negative 1. And then we just keep going with our product rule. So we're going to have that plus derivative 2t, keep the same, e to the negative t. So right here, you've got a chain rule within a chain rule, but you can do it and it's not too bad as long as you just make sure you start at that outermost function, the cosine, and then keep working your way in, and you're just careful to recognize that you have to do chain rule here since you've got another function with that negative t. Okay, so 15, I'm finishing off 14 with those arrows, underlining. We'll just move on to 15. So 15 is, I think, a really tricky one when you're identifying where to start with the chain rule and you're identifying what's the outermost and what's the innermost function. So I'm just going to work through that. Obviously, your outermost function is the tan. I'm circling this one just because it's a tricky one, I think. So that outermost function is the tan. And then here you've got tan of cosine of sine of x. So you've kind of got like a double chain rule going on. So if you look at this, I'm going to call everything in those wide parentheses the inner function. And then I'm going to call the sine of x the innest function because it is inside the in, which is a little bit tricky, but we will work through it together. So looking at all of that, I'm going to go back to that tip that I talked about on the other page. If you think about plugging in a number, say you're plugging in 1, then you're going to plug it into that sine of x first. So you know that that's the innest function. And then you would do the cosine to whatever number you get there. And then you would do the tan to that. So that is just a good way to think through identifying the outermost and the innermost function. And then just remember that we're going to work from the outside in. So let's get started with this one. Remember that the derivative of tan x is secant squared x. So we're going to do y prime equals secant squared. And then you do the in function. So everything that's in those parentheses, you're going to do all of that, cosine of sine of x, not changing anything because g of x stays the same. And then when you multiply by g prime of x, remember that the outer function there is the cosine. Co means negative, so you've got negative sine of the g of x is the innerst function sine x. And then you've got one more step to do. You multiply by that innermost g prime of x. So in this case, it's going to be cosine of x. So here is just a good example of working from the outside in, doing it one step at a time. And just keep in mind that you've got all of this cosine of sine of x as the g of x for the tan function. But then the g of x for that inner function is the sine of x. Okay, so hopefully that makes sense. We'll get some more examples of where it's hard to identify inner and outer function. So let's just keep working through these. On 16, I think this is a really good example of how to recognize the inner and outer function. So let's start looking at that after I do my rainbow underlines. On 16, you've got a tan cubed of x, and anytime I see a trig function and then an exponent and then an x, any problem, I think it's really helpful to rewrite that as the trig function, as putting the exponent on the outermost part of the trig function. So when I rewrite that, y equals, I'm going to do tan x to the third. So that just makes it easier for me to be able to recognize it as a power rule problem. And then I'm just going to finish rewriting it, plus tan x cubed. So this is kind of like that first example I started with the sine x and then the sine x squared, where you want to be able to identify the inner and outer function. So in this case, that first part, you've got the inner function as tan x and the outer function as the exponent. But then on the second part, your inner function is the x cubed, because that exponent is attached to the x. But in the first part, the exponent is attached to the tan x. So you just have to make sure that you're careful about that before you start working through it. And then once you rewrite it, I think it's a pretty simple chain rule problem where you're going to do y prime equals, do the power rule with the 3 times tan x squared. I should have put some parentheses there to make it clear. And then you're going to multiply by the g of x here is the tan x, so the g prime is secant squared x. And then you just move on to the second part here, and you're going to have secant squared of g of x is x cubed. There we go. And then multiply by g prime of x, which is 3x squared, using the power rule on that inside function. Okay, so 17 is another kind of problem where people tend to get a little bit tripped up with just that little 7x, so we're going to be careful as we do that one. So this is another product rule. You can see that you're multiplying two things, and so we're going to identify the first part as secant 7x. I didn't underline it on this one, but just know that the first part is that secant 7x, and then the second part is going to be the ln of 7 to the x. So I just wrote out this derivative because I think it's a tricky one to remember. But just remember that the derivative of secant x is secant x tan x. And the tricky part here that gets a lot of people is that you've got this innermost function where you're multiplying x by 7. So you have to remember that when you plug in that inner function as you're doing the derivative, you have to keep it as 7x. So I'm going to write it out and show you. You're going to have y prime equals secant 7x, because of that 7 right there, times tan 7x. Both of them have to have the 7. And then to do the chain rule here, remember that our innermost function, our g of x, is 7x, so our g prime of x is going to be 7. So that derivative gets multiplied by 7, and that is our derivative, and then since we're doing product rule, we multiply that derivative by our keep the same, which is ln of 7 to the x. And then I'm just going to point out here those arrows that I have pointing to the chain rule. Remember that since both of those are 7x, you don't have to do it twice. Since the g of x is just 7x, the g prime of x is just 7. You don't have to do g prime twice, even though you plugged in the 7x for two different x's, okay? So continuing with the product rule, we've got derivative keep the same plus keep the same secant 7x times the derivative. So the outer function on this second part is the ln, remembering that the derivative of ln of x is 1 over x. So we're going to start with that outermost function doing 1 over, and then our x here, our g of x is 7 to the x. And then to do chain rule, we move on to the innermost function. The g of x is 7x, so the g prime of x, using that derivative that says a number to the x is the number to the x times ln of the number. We're going to multiply by 7x, ln of 7. The 7 kind of gets cut off there, but just imagine it. And I'm going to write the derivative. That derivative rule states that a to the x goes to a to the x ln of a, and it kind of gets cut off again, but you can imagine it. So we've got a lot going on number 18, but basically this is a quotient rule problem with chain rule in it. And we've done a little bit of like rewriting things on this worksheet, so I'm just going to remind you that I pretty much always rewrite things when I've got basic fractions like this 1 over x. I always rewrite that as x to the negative 1, or anytime that I can turn a fraction into a power rule problem, I do that. The other time that I rewrite things, like I did a couple problems ago, is when I have a trig function with an exponent. I always move that exponent to the outside of it. So in that case, I had a tan cubed of x, and I rewrote that as tan x cubed. So those are the times I'm rewriting things. In this case, I'm going to rewrite the sign of 1 over x as sine of x to the negative 1. And then everything on the bottom stays the same. I've got 1 plus x squared. So I am going to identify that as a quotient rule. And as I'm doing the quotient rule, I have to pay attention to the inside functions like this x to the negative 1. So we'll just point those out as we go. So remember, quotient rule is low d high minus high d low over low low. So we're going to start with the low, 1 plus x squared times d high. This is where our chain rule comes in. So our derivative is cosine of 1 over x times the derivative of that innermost function. So in this case, I've got my g of x is x to the negative 1. So when I start on the outside, which is that sign, I'm going to do cosine of x to the negative 1. In this case, I just wrote it, I went back and wrote it as 1 over x times, if that's our g of x, that 1 over x, then I'm going to multiply it by the derivative of g of x, g prime of x. And so that's going to be negative 1 over x squared, using the power rule with that negative 1. So that's my low d high minus high d low. So that's going to be minus, or let me write the arrows. So that's where I did the chain rule. So minus high d low, that's minus sine of 1 over x times, that's an easy derivative, 2 of x. And then you just do all of that over low low. So that's going to be 1 plus x squared, and then a squared on the outside of that. Okay, so for this last one, it's not too bad, but these inverse trig derivatives can make things a little bit tricky. So let's just work through this. I had to add another piece of paper because I ran out of room. But I'm just going to write a reminder here that the derivative of the inverse cosecant is, okay, it's focused now. is negative 1 over x times the square root of x squared minus 1. So that's just to help you remember that derivative. And now we're going to get started with the problem. Here I've got a square root, which I like to rewrite because I think that makes it a lot more simple as you start doing the derivatives. So I'm just going to rewrite that as the inverse cosecant of x squared minus 2 to the 1/2, changing that square root to 1/2. And so now getting started here, I am going to start doing that derivative, and just remember that the innermost function is everything that's inside this parentheses. So every time that we have an x, like this, x times square root of x squared minus 1, every time we have an x, we have to plug in the entire innermost function. So it's going to get a little bit messy here, because we're going to have a negative 1 over, and then our x is everything inside the parentheses, so square root of x squared minus 2. And then we're going to have a big square root. X squared is going to be square root of x squared minus 2 squared. Remember, we're plugging in all of that every time we see x. So we're going to square, and then minus 1. So that's just plugging everything into that derivative. And then finally, we're going to do the chain rule here. Remember that our g of x is the inner function, the square root of x squared minus 2. So to do the g prime of x, we are going to look at the way we rewrote it here, rewriting it as x squared minus 2 to the 1/2. And that 1/2 tells us that it's a power rule problem. So let's do power rule, bringing the 1/2 to the front, times our g of x, x squared minus 2, to the negative 1/2 to finish off the power rule. And then again, we've got to be careful recognizing this as a chain rule within a chain rule. So our inner function with that is the x squared minus 2. So we're just going to finish off by multiplying by, here are my arrows pointing out the chain rule. So we're just going to finish this off by multiplying by 2x. So here you've got the outermost function is that inverse cosecant. So we plugged in the inner function for that everywhere we saw an x, and that's what you see all over here. And then our inner function was the square root of x squared minus 2, so that arrow takes us to this power rule problem. And then the innest function is the x squared minus 2. So we're going to do chain rule again with that 2x. And that's the last example problem, so congrats for making it through the worksheet. I know this concept can be a little bit difficult, but the more example problems you do, I really think it'll come more naturally to you, and it'll start seeming a lot more easy. So if any of this was confusing, or if you forgot a lot of these derivatives, remember to go check out some of the earlier videos. And there are also some review videos on derivatives. And if you thought this was helpful, remember to like and subscribe to the channel. And there's also a Discord channel, and the link will be in the description of this video. So you can go to the Discord, and there are different channels there where you can get help with calculus, or even if you're working on the ACT, you can ask questions, find some practice tests there, and there are going to be people like me that can help you with that. So I hope you enjoyed this video, and I'll be doing some more videos in the future. Thanks!